All right, folks, let's go ahead and do this fifth homework in our series. This is 10.5 homework, or the homework number 5, right? We want to draw a second normal curve. Normal means it looks like a bell, like how all of these are. All of these look like bells. Okay, so we want to draw a second normal curve, which looks like a bell, on the same axis as the first with these new properties. So this first one says we want the mean to be the same. So right now the mean or the average is right there. That's the mean. We want the mean to be the same, but we want it to have a larger standard deviation, meaning that the information, all the data is going to be further away. So I'm going to go ahead and do kind of like something like this. Right? Meaning that there's going to be more information further away from the mean or the average. Okay. Number 2, the mean is the same. So again, the mean is where the highest point is, roughly right there. I'm a little bit off, but no biggie. And the standard deviation is smaller. So meaning that, for the mean to be the same, okay, that means that it has to line up in the middle as well, okay, so the mean needs to be the same, but the standard deviation is smaller. So that means that all these data on the outside here, they all need to come into the closer to the average, to the mean. So that's what it means. Okay, so which means that if I do this, it's going to have to look, kind of like that, which means that I have more information, more of my data is close to the center where the mean is. Okay, the mean is smaller, okay, and the standard deviation is the same. So again, here's the mean right here. So I just need it smaller. That means that my mean needs to be somewhere else. So I'll just do it over here. Okay, standard deviation, meaning that the shape and how spread out my stuff is, it's going to be the same. So that means it's going to have to look exactly like how this one is. So I need this one to be over here. So that's what it would look like. The mean is smaller, okay, and the standard deviation is the same. The mean is larger and the standard deviation is the same. So that's actually just exactly the opposite of what I just did. So the mean, again, right now the mean is right here. And I need the mean to be larger. So I'll just go, you know what, maybe just a little bit, right? We don't need that much. So I'll go, okay, well, my new mean is right there. It has to be bigger. And then my standard deviation is the same, meaning that it's going to be just as widely spread or as closely spread as this one is. So I'm going to go ahead and just copy it down and just put it like that. That's my larger mean, but same standard deviation. Okay. If you need to pause it and think about it, pause it, think about it, rewind it, whatever. Okay. The mean is smaller and the standard deviation is larger. Okay. So again, here's the mean for this one right here. And I want this mean to be smaller. So I'll say, way over here. That's my mean. But the standard deviation is larger, meaning that more of the stuff is further away. So that means it's not going to be as high up. The stuff is not going to be as close to the center as I need it to be. Okay, it's going to be further away. So what that means is it's going to be more like, so it's going to be lower and wider. Okay. Remember, they all sort of should look like a bell. Okay, normal curve. The mean is larger and the standard deviation is smaller. So here's the mean. Okay. And I need it larger, so that means that it has to be over here. I'll put it over here. And the standard deviation is smaller. That means that all these data here, they're going to be closer to the center. All these data here, going to be closer to the center. That's what it means. So it means that I'm going to have a higher graph, but it's going to be very few that's going to be so far away. Okay. All right, that's the first page. Second page, make a comparative statement about the distribution mean and standard deviation. Use words like bigger, smaller, and or about the same when comparing the two distributions. So basically, we're doing just the opposite of what we did on the previous page. Okay. So this first one, right? So distribution A has a blank mean. Now look at distribution A compared to distribution B, right? Well, distribution A, the mean is less, so smaller. So we can say smaller. Mean because the center is to the left of distribution B. Okay, that makes sense. Distribution A has a blank standard deviation than B because it's not spread out as much, right? So B is closer together. You see how all the information on B is like very close to the average, the center. Okay, and look at distribution A. They're further apart. So distribution A, okay, the standard deviation is much larger. So distribution A has a larger, well, we can say bigger because they do use the word bigger up there. Distribution A has a bigger standard deviation than B because it is not spread out as much. And the same distribution B is not spread out as much. Okay, distribution C and distribution D. Okay, so we got to talk about both. So I want to say distribution C has a, and then looking at C and D, we want to say a smaller mean than distribution D. Okay, reason is because its mean is to the left of distribution D's. Okay. Also, distribution C has a similar, or has this, we'll just say the same, has the same okay, what did they ask us to use up there? And about the same, right? So we can say about the same, but I'm just going to say the same. Distribution C has about the same or has the same standard deviation as distribution D. And how do we know this? Because they both have the same shape and spread. Okay. Meaning the spread out and the shape the same. Okay. 27. We'll use blue. Let's see. Distribution E has about the same mean as distribution F. Okay, how do we know this? This is because the highest point okay. Why don't we just say because the mean? Okay. The highest point is where the mean lives, but because the mean are in the same place. Okay. Distribution E has, let's see, E is tall and skinnier, which means that the standard deviation is, what do you think? That means everything is closer to it, so standard deviation is smaller, right? So distribution E has a smaller standard deviation than distribution F. Okay. Since more or since it is taller, meaning it is not as spread out as much. Okay. And last one, distribution G versus distribution H. Okay, we want to say distribution, abbreviate G has, and we'll talk about the mean first, a smaller mean, which is the average, than distribution H, since or because its mean, which is the highest point right there, where the highest point is located, versus the highest point here, since its mean is more to the left. Distribution G has a smaller standard deviation than distribution H, since it is not as spread out and I'll say is taller. Okay, if you think about it, if something's taller, that means that everything is more towards the center of it. All right, I think that's it.